So why don't we jump into making an application? Like I said at the beginning of the stream, it's been a while since I I took a vacation for the break, and so I am going to be going off the docks just like anybody would because it's not super fresh in my memory. And what we're going to build is a simple application for exploring a hyperdrive. It's going to be a simple web app. So I'm going to make in my temp directory simple app. I'm going to do an npm init. And so the first thing you're going to do, since we're using the daemon, is you're going to install the daemon, the Hype CLI, which I've already done, and it's already running, so no need to do that. We have a way for you to be able to programmatically run the daemon, but I don't need to do that either, because it's already running on my device, so we're just going to skip that. And instead, we're going to jump right here to programmatically connecting to the daemon. So the first thing we're going to want to do is get the Hyperspace module. And while that is installing, I'm going to set up my VS Code. I'm going to go to temp and simple app. Okay, and now I'm going to create an index.js. And for the first thing that we're going to do is we're just going to establish a connection to the client. So we'll grab the client API here, and we'll create a new instance. And basically, since there's a daemon running, it's kind of like having a server. And so we need a client to that server to make API calls to it. And so that's what we're going to do with the Hyperspace Client right here. So we'll instantiate a client object. And there's going to be some async code, so I need to... Well, let's see, do a quick experiment. I'm trying to remember if async await has landed in the version I'm in. 14, probably not. The top level await, rather, but let's find out real quick. Yeah. Top level await has not landed yet in the node version I'm in, so I'm going to have to lift into a function. Make the font a little bit bigger. All right, let me know if that's big enough for you. All right, so we're going to create a client instance. And so that is going to connect to our daemon, no problem. Just the default daemon that's running, so no parameters needed. And then what we're going to be doing first is just making sure that this thing works. And so I'm going to load up a hyperdrive and read out the contents of it, and I'll use the test hyperdrive that I created earlier. The hyperdrive module comes separately from Hyperspace because it actually just kind of builds on top of it. So I need to install that as well. npm I hyperdrive, and then I'll import it. And let's pass in a key to main. And it'll be a string. So what we're going to want to do is instantiate the hyperdrive. And hyperdrive is, in this case, going to take in two parameters. The first one is where data is being stored, and the second one is the key that we're looking to load. Now, since we're using Hyperspace, it has its own core store where it manages all the data, and so that's what we're going to pass in, is a instance to the remote core store, right there. And then we're going to pass in the key. And the key needs to be in a binary buffer as opposed to a string. So we're going to do buffer.from keystring hex, and then we'll pass that in. And I'm going to grab the key of the hyperdrive we created earlier and pass that in. So that'll create our Hyperdrive instance there. And then we're going to wait for it to be ready. Now, Hyperdrive's default API is callbacks based because it was made. Hyperdrive was first made, I want to say, like 3 or 4 years ago, maybe. So normally you would do it like this. But since we're getting with the times, we added a promises layer, which you can access by using the promises sub-object. So now the promises version of the APIs are all available like that, drive.promises. So this is going to, I don't actually think it's strictly necessary in this case. There are some attributes on the drive object that will get populated after the ready event has fired. And so if you await for ready, you'll be able to log them out. For instance, the discovery key on the drive wouldn't populate until after that. And why don't we confirm that I'm right about that by running this quick test. So if I do this, it should, yeah, null because I didn't wait for ready. Now if I wait for ready, there's that discovery key. So that's what the point of ready is, but we don't need to do that right now because we're just going to call readDir, which, you know, internally it's going to wait for ready, so there's no need for us to wait. And there we go. We just read out the files inside of the Hyperdrive. Simple enough. So the API to Hyperdrive, let's see if there's any more sort of any more that we need to. Ooh, that might be wrong. Come back to that later. All this is fine. All this is fine. Yeah, okay. So now if we jump over to the Hyperdrive API reference, it looks more or less like a sort of the NodeJS FS interface. So you got things like read file, create write stream, write file, unlink, mkdir, rmdir, etc. And so what we're going to build now is a little localhost web app for clicking around inside of our Hyperdrive. Really simple use case, you know, just to kind of show, you know, the basics of how to use this thing. So to do that, we're going to need to create a NodeJS HTTP server. And let's see how good my Node API memory is. Okay, so I'm going to pass in a request listener, which would be rec and res.write head to 100.end hello world, and then I'm going to call listen on 8080. Okay. All right, got our localhost server running. And so what we're going to do is basically treat the localhost as a pass-through to the Hyperdrive so that whenever I make a request to anything, the path will get routed to the Hyperdrive and load up whatever file or folder is there. And if it's a folder, it's going to list out the files inside of that folder and give links to them so you can navigate around. So we'll start by just doing a simple dump of the files. And I need to make this async. Okay, and there's that dump of the files. So next we need to get some logic in for sort of routing the request to the path to choose what file or folder we ought to be rendering. And now I got to try to remember if the Node.js request, I know it has URL. Does it have a path? A path name? Let's take a look. There's path, and then I'll go ahead and dump the request object as well in case I'm wrong. So let's see. So it's not path. It might be path name. Let's try a couple. This is level when that output is totally useless. Let's try path name. If anybody in the chat remembers what I'm looking for here, I'm pretty sure rec.url is in there. Okay, rec.url is our winner. A little weird, but okay. Rec.url is the path. And so, first thing we need to figure out is what's at the path. So we need to run a stat on the hyperdrive at that path. So we'll call a stat command. And that's going to give us some information about what we are looking at. And here's that stat. Now this is the sort of unhelpful view because what we need to do is interpret the mode to figure out what exactly the object is. And so we use the same as node. Is it a file? Is it a directory? And there we go, and we are looking at a directory. So, when that happens, we now have a branch. If it's a directory, we respond there, and if it's a file, we respond here. So if it's a directory, we'll do a redir at the path to get the files out. And if it's a file, we'll grab, well, we can grab the content, but actually that's not what we're going to do here. We're going to do it differently. We're going to want to stream the response. And we'll get to that in a second. So for now, we'll just say, give it a to-do response. But for the directory, we need to craft a little HTML. And so we'll do that like this. We'll do a template string. Not going to worry about the fact that the spacing is going to be funky on the response. Doc type HTML5 or just doc type HTML? I think it's like that. It doesn't really matter. And then inside that response, we will map through the files. We'll put each one in a div. And then we'll serve that response. Okay, and we did pretty good, except I forgot to call join on the array there. This is why nobody ever builds web apps this way, because this is a terrible way to build web apps, but we're doing it like this. All right, so now we're getting that in HTML. Those each should be wrapped in a div. I'm sure they are. But that's not all we want to do. We also want them to be links to the individual files. And so maybe div and then an ahref, and we can actually just do the plain file name as opposed to constructing a URL, because they will come out as regular URLs, or relative URLs rather. Okay, so now they're links, and if you look down, you're not going to be able to see this, but the links look correct in the bottom left, but of course we're getting it to do when we actually click through to them. But you can see the URL is correct right there. So let's add some more information in our Hyperdrive real quick so we have more to test against. So I'm going to do mkdir dir1 type drive mkdir. Okay, and dir2. And then inside of dir1, we'll put a file real quick, like hello, and pipe that into dir1/hello.txt. And then I'll restart our app, refresh dir1, there it is, hello. Now, looks like, interesting. Okay, that's interesting. So we ran into a bug right there, and a couple of bugs. Okay, good stuff, good stuff. So the first bug that we ran into there is dir1, the relative path didn't work correctly. Y'all can't see this, but what it's linking to is /hello.txt as opposed to /dir1/hello.txt. And the reason for that is that I don't have a trailing slash. And that's a problem for our relative URL resolution. So let's get a redirect in here. If it's a directory and the path doesn't end in a trailing slash, let's just redirect it to add the trailing slash. And now we're really going to test my HTML knowledge, or my HTTP knowledge, because let's see if I can remember how to do this using URL codes. I believe it would be 303, and then location path plus the trailing slash. Okay, let's see how this goes. Nailed it. Okay, now when I click on this, it'll work semi-correctly. Didn't quite work. Interesting. Should be seeing to do. Why don't I see to do? Huh, that's interesting. So this, oh, it did a trailing slash on hello.txt. Why does it think hello? Did I do mkdir on hello.txt? Let's see. I did. Hello.txt is actually a directory, so that's not right. Let's rm.dir. And then let's do our command again, but this time it should be put, not mkdir. Okay, now it's, as soon as I start my service again, it's actually a file. Okay. So, making progress. One other thing I'd like to have is if you're not in the top level, there should be the little two dots to let you go up a directory. And that's pretty simple to do. We just take a look. If the path is not the root, then we're going to add the link. One thing I should point out is that you definitely shouldn't do what I'm doing in any real application, which is taking the file listing and just dumping the file names into the HTML unescaped. Depends on what your situation is. If you trust the hyperdrive that you're loading from, not a problem. But if it's like some hyperdrive that any random person could give you, you would actually want to escape these file names before putting them in, because they could be used for HTML injection. But we're not going to worry about that right now. And there's our up directory bit. Okay. So now we have one more task. And that is to actually output the contents of files whenever you visit them. And for this one, we're going to use create read stream. So we'll do a write head of 200. And then we're going to do create read stream on the path. Not create stream, create read stream. And we're just going to pipe that into the response. And as a result, you get the file. Simple as that. And there's our really, really simple Hyperdrive exploring application. If we wanted to, we could do this another way. We could make it content equals drive.promises.read file. We could just read the file into memory entirely, and then do res.end content, and the same results will occur. Outputs just as before. The difference is that it's just a little bit, on larger files, less efficient, because you're now loading up. I mean, it's less efficient always, but especially on larger files, this means that you're reading the entire file into memory before sending it out to the browser, and there's really no need to do that. You can just have it so that every time a chunk is read out of the drive, it gets piped directly into the response stream and kind of cleared out of memory immediately. And so that's just a slightly more efficient way to do this particular thing. So there we have our very simple Hyperdrive loader. So let's see, how many people? We still got 10 folks in the stream. We could take this to the next level if y'all are interested, and the next level would be getting this thing to handle multiple different kinds of hypercore data structures. For instance, make it so that it correctly handles when you load up a Hyperbee in addition to a Hyperdrive. And what that would entail is detecting what kind of data structure we've landed on, and then changing the behavior of our response handler accordingly. A little bit more work, to be sure, but we could do it. One thing that I didn't, so yeah, I don't know, say in the chat if you'd be interested in that, and if not, I could just switch to sort of general Q&A, or build something else, or show how to do something else. More than happy to do that. One thing that I did not get into with this is basically this application is reading out of the local cache only. It is, so if I were trying to access a hyperdrive that were not in my local cache, I didn't create it or I haven't synced it previously, this application would fail to load it. And to do that, you would need to get the hyperspace to go onto the network for the hyperdrive. And the code example that we had looked a little wrong, so I need to look into what that is. But there's a really simple function you use. If I go to the Hyperspace API here, it's just the replicate command on the Hyperspace Client. So if I call client.replicate, now here's the thing that I'm a little unsure of. If this thing is working the way that it ought to, you ought to be passing in the drive, and that's what makes sense to me. But I think actually that's wrong. It is wrong. You have to pass in an individual hypercore, and that is a little confusing, but I'm going to go ahead and explain what that is. Every hypercore-based data structure is built on hypercores. And really, for now, that you just, this Hyperdrive Hyperbee. My chair is falling apart. 1 second. The wheels came off. It's a bad metaphor for my stream. All right, hang on. Okay, hopefully that won't happen again. What was I talking about? Okay, yeah, so you got hypercores that the structures are built on top of. For Hyperbee, there's just the one hypercore. All the data is written onto it. And so in Hyperbee, that hypercore, you can access it as the feed attribute. Wheels, how do they work? Feed, log, it's kind of means the same thing. So if we were doing a Hyperbee, it would be b.feed to get the hypercore, because you need to pass a hypercore into the replicate function. In the case of hyperdrives, it's actually 2 hypercores, and if you're really getting deep into it, it could be more than 2 when mounts get involved, but we don't need to worry about that. But there are 2 hypercores inside of a hyperdrive. There's the metadata one, and then there's the content one. The metadata one is where all of the sort of, well, the metadata is listed, so like the file listing. All the information about like what the file names are, what directories there are. It's actually sort of like those stat objects you saw whenever we do a call stat right here. What it's actually doing is just reading the information, the stat information, directly out of the metadata hypercore. So like the entries are like a collection of those stats structures. And then the content hypercore is where the actual bits that comprise the file are stored. So you have these 2 different hypercores side by side. I imagine a lot of people in the stream already know this, but if you don't. And so the reason that we do this is that this means that you can actually list out all the files in a hyperdrive without having to pull down the drive, the file contents. They're kind of kept separate. So then you look up the content of a folder, you find the file you're looking for, and then you can reference over to the core and pull out just the blocks you need. So it's sort of an efficiency thing. And so that's why in the case of a hyperdrive, the metadata drive is sort of like the identifying hypercore or the root hypercore to the hyperdrive. It's the one that its key is what is used to identify the hyperdrive. And so whenever you're calling replicate, what replicate is doing is it's going on the network and announcing like, hey, I got this thing. I'm looking for people that also have data for it. You're swarming. And then whenever you connect to people, it's going to exchange the bits and all that. So that's what the replicate function is doing, and you're passing in the hypercore that identifies the data structure. In this case, that would be the metadata drive, metadata core on the hyperdrive. So that's what that is. Let me know in the chat if that was in any way unclear. But I got 2 thumbs ups for the Hyperbee stuff. So let's do that. So I think the way I'm going to handle this is I'm going to start by basically putting all this code aside and then building a Hyperbee specific script. And then we can merge them together and make it intelligent enough to correctly detect which structure we're looking at and give the correct handling accordingly. So we're going to create an async serve drive function. Got a question. So the replicate on the content happens automatically. Yes, it does. And it's replicated on what you call on demand. Sometimes we call that sparse replication, which basically means that whenever a peer makes a request, they will only download the files and the pieces of metadata that they need to serve that request. So if I start swarming somebody's drive and only ask for the index.html, that's the only file I will download into my local cache. If you want to download the whole thing, you can command it to download the whole thing, but by default it does not. So, I'm going to create the serve drive function, and I'm just going to move all this code over there. And we'll save that for later. And I'm going to remove the replicate bit. We're just not going to worry about that for now. And I'm going to comment this out. So we're doing Hyperbee now. Same as Hyperdrive, we install the module separately. Oh, you know what we didn't handle, which would probably be smart to handle, is we didn't handle not found, a 404 condition. Why don't we do that real fast? And then we'll get into the Hyperbee. Just this is pretty easy, but it's still worth doing. So we'll call serve drive function. And it's pretty straightforward. We're just going to wrap this stat in a try catch. Well, let me think. Const is block scoped, is it? Is const block scoped or lexically scoped? Oh, it looks like it is Block scoped. Nope. Ah, it's lexically scoped. Okay, that's what I thought. Ugh. Try catches and lexical scoping. There we go. So wrap it in a try catch, and so like stat will throw if the file doesn't exist. Simple as that. So if that happens, we just do a res.write head 404 and then file not found, and we return. Oh, there we go. File not found. All right, now let's get into the Hyper-B. So, first things first, I'm going to install Hyper-B. So one of the cool things that's happening with this is basically Hyper-B and Hyperdrive. This is a really pretty elegant thing that Andrew and Matthias managed to put together, where Hyper-B and Hyperdrive, really their main dependencies, they need to know where their storage is. But the reason they need to know about the storage is so that they can get access to the hypercores that they're built on top of, right? And they don't care whether or not they're getting the native, hypercore module. So if you're using the individual modules, you could pass in the hypercore directly, or if it is a sort of facsimile of that API, which is what it is in the case of Hyperspace. Like the core store response here, like it's basically in the Hyperspace API, there's this remote hypercore API that looks almost exactly like the normal hypercore, but it's actually talking over a socket to the Hyperspace daemon. And so you can have the remote hypercore or the normal hypercore pass them in, and Hyper-B and Hyperdrive are completely agnostic about where they exist. So in theory, this Hyperspace client could be connecting to, we don't have the mechanics for this quite yet, but it's pretty straightforward that the actual Hyperspace daemon could be running on a different device. And I would just be setting up the Hyperspace client to connect to that other device and passing in the remote hypercores, and it would work just the same. So that's why you install Hyperdrive and Hyper-B separately from Hyperspace, because Hyperspace doesn't actually, that whole thing doesn't actually know about Hyperdrive or Hyper-B. It's completely agnostic to the high-level data structures built on top of it. So that's why we are installing those modules separately. And so now I'm going to import my Hyper-B here. And I'm going to comment that out for now. And what is my usage for Hyper-B? Like I said, I got to check the docs, same as anybody, because it's been a little bit too long. All right, so yeah, you pass in. Yeah, so this one is slightly different. With Hyperdrive, you pass in the core store itself because it needs to load additional hypercores. It has some kind of logic in it for, you tell it which key you want to load, it's going to look up the hypercores as needed. With Hyper-B, you're not actually giving it the core store, you're just giving it the remote hypercore, or the hypercore interface. So in this case, I'm going to be doing client.corestore.get, and then passing it the key. So basically I'm getting the hypercore that the Hyper-B is built on top of, and then I'm passing that hypercore into Hyper-B. So to do this, I need to create a Hyper-B for us. Oh, that's right. Yeah, this is actually a known bug, but it should still work. But that dump, ignore that. Known issue that I need to tackle pretty soon. So Hype-B ls. Okay. So I'm writing a couple of test entries into the Hyper-B. And so what you can see here, I kind of got silent there because, again, don't remember how I wrote this thing, so I had to just try it before I talked. So, like I said, Hyper-B is a sort of level DB-like database, key value store. And so I called two put commands, writing the entries 1 and 2, and giving them the values first entry and second entry. And then when I call an ls inside of it, it's listing out those key values. Pretty straightforward little bit there. So this is going to be our, our Hyperbee for testing. And so let's take the drive key and save it as a constant for later. And then we'll take our B key and pull that out now. Okay, and that should now give us access to the Hyperbee. Now, with a Hyperbee, you can pass in information about the encoding so that it kind of automatically encodes the keys and encodes the values in a way that's useful. I'm trying to remember what I think this is actually the default encoding that we're pushing here. It's not the default encoding if you don't pass anything in, but I'm pushing for us standardizing the encodings across the board for convenience. But anyway, so we'll do binary key encodings and JSON value encodings. Yes, we'll be actually. For the sake of this video, we're just going to use UTF-8 keys. I actually recommend using binary key encodings, and all right, don't worry about it. We'll just do UTF-8 for now. So to make sure that everything is working correctly, we're just going to do a b.list, and the list function actually is a stream, which is a big pain, so we're not going to do a list, we're going to do a get. I have personally mixed feelings about streams. They're kind of a pain. But anyway, so let's just make sure that the get works. Okay, this is something else we need to get around to. Hyperbee does not have the same constructor pattern as Hyperdrive, so we need to fix that. But okay, there we go. So now we just got the value of the item at key 1. And get actually outputs an object, sort of a wrapper object with this metadata about it. Which is sort of interesting because not only do you get the key and the value, but you also get the sequence number, which tells you sort of like what the revision of the write was. So if and when you get into versioning your data sets, that becomes a useful piece of information. So now we have get handled. And so now we need to write our Hyper-V server. And I am going to do a copy and paste here. But, let me think. The mechanics are going to be a little bit different because Hyper-Bs are not like Hyperdrives, of course. They don't have a notion of folders versus files. There is a mechanism for doing subdrives that we're sort of in the process of subdatabases, similar to LevelDB kind of sub-levels. But that's still in the process of getting standardized. The default stack hasn't quite matured this part of it. So really there is 2 operations that we have at our disposal right now for reading the thing. A list, which is going to list out a range of the data set, and then a get. So there's no stat. So we can't ask okay, are we looking at a container of values, or are we looking at an actual value? So the way I'm going to build this for now, and this is sort of evolving. So take this bit for as a kind of a temporary situation, not as gospel, but this aspect about how the sub databases work, the sub Bs. But for now, we're just going to say if you're looking at the root, just list out everything, and if you're looking at an individual item, just get that. So that means that our logic is slightly different. Rather than is directory, we're just going to see if the path is at root. And then if it's not, it's going to be an individual get. So for the list, let's get over to our API reference. Actually, this is all we need. A little cheat sheet. For the list, we're going to do create read stream. And I'm going to do it like this. Await new promise. I'm going to get some stream helpers. I'm going to install concat stream and pump. Because nobody in the world ever wants to just use vanilla vanilla NodeJS streams. So I'm going to do pump, and I'm going to do the b.create read stream. I'm not going to pass anything in, just going to get all the entries. And then I'm going to do concat, which should get us all the entries, and then I'll just resolve with that. And then the last parameter of pump is the error handler, which if that happens, we just call reject with the error. Look at all that boilerplate. Yeah, do not personally love streams. Anyway, so there we have entries, and I'm just going to log that out to see what it looks like, and then I'm going to do a res.writehead to 100.end to do and return. One last thing. We got to call our serve_b function. And let's see how we did. Okay, misspelled concat stream. Can't do that. Try again. Okay, so there's that get. Left that in. Let's pull that out. And let's see what happens when I load the root resource. Okay, to do, correct. And there are our entries. And then we got a reference error, so I need to fix that. But okay, so exact same kind of output as the get function, just a list of them now. So now let's dump that out onto the page. And notice it includes the values. So unlike read dir, you're actually getting the values. Now where does that drive come into play? It was bugging because we had drive in there, line 67. Huh. Oh, you know what? I bet a fab icon request is going on in the background. That's probably what that is. Okay, so we got our entries. So now we need a similar thing to this. We just take the HTML. Don't need the double dot up. But we do need entries. And we're going to be using the key. And then we'll do a equals and then the value. And then we'll do sequence equals entry.sec. And let's take a look and see what we got. There we go. There's the listing of our Hyperbee. And now let's just do the get, which is real simple. We just do const entry equals await b.get at the path. Need to wrap that in the try catch so we could handle 404s. And we'll just dump the entry value when we do this. And when you 404, we respond with the entry not found. And it broke right away. Now let's see. It may have a leading slash on the path, and we may need to remove that. It does, so we'll just do a quick little slice. So that'll cause, slicing it one character in, that'll cause it to drop the leading slash. There we go, first entry. Can the value be a JSON object? It can. It can be a JSON object, so why don't we get an example of that. So if you want to write package.json into Hyper-B using the hype command line. Well, let's write the package.json. So you can't do, we want to use the put command to add it. And you can't just put the JSON in here because there is an escaping nightmare that comes into play where you need the double quotes inside the JSON. And so to get around that, what we'll do is we'll create an our JSON entry, and I'm just going to cat the package.json and pipe it into the put, and that will make it work. And it's intelligent about the fact that, okay, that's JSON. And now I need to start our script again. And there we go. It's JSON encoded. So we need to actually do JSON.stringify on the values. And this will look like holy hell because it's a package.json. So, oh, interesting. What are you doing here? Didn't I just... Oh, I didn't save. Yep, there we go. Yeah, not too bad. And if I click on it, there it goes. Okay, so now we have a Hyper-B quote-unquote browser. Step 2 complete. And now it's time for step 3. Before I move on, does anybody have any questions? So, while I give space for questions to come in, I'll explain what's going to come next. So first of all, you know, I could make it so this thing, how do I want to do this? We could make it so that it reads the key off of the path and all that, but I'm just going to make it so that whenever the thing starts, I choose to pass in the drive key or the B key, and it just adapts accordingly, rather than, you know, because it's really just for an example. And so we're going to have a, we'll just say const is drive, and we'll detect if it's a drive or a Hyper-B, and then we'll just call the logic accordingly after that. So, okay, time for questions. Is there a way to access the keys as files or convert them to files? Mario, I assume you're asking, is there a way to like access the Hyper-B's listing of keys and treat them like files? Now, when you say access them like files, are you meaning like using Fuse, like make it seem like the native file system that the operating system is rendering, or explain a little bit more what you're looking for there? Ryan asks, Mario, yes. Okay, so the Fuse interface is actually sort of not maintained at this stage. We kind of put that down, put it aside, said, okay, that was cool, but kind of a kind of a nightmare to get right. And so it's there for somebody to pick up at some point in the future. But you know, you got cross-platform problems. Windows isn't supported. You get all kinds of weird glitches that come into play between Mac OS versus Linux, et cetera, et cetera, et cetera. So we just kind of put a pause button on that. So there's not currently any Fuse interface written for Hyper-B. The Hyperdrive Fuse interface still works correctly and everything, but we're just not kind of focusing resources on it at the moment. If you were looking to export the key listing as a file, I mean, you could just use the Hyper-B, the hype command line to do the BLS and then like, you know, dump that into a file or something like that. But there's not currently a way to like do the reverse, to take a dump of a Hyper-B in file form and like hydrate in a Hyper-B. Probably a pretty easy script to write if somebody were inclined. Ryan asks, so it seems like you could almost leverage Hyper-B to be a kind of pub sub if you wanted. Is that reasonable? You need to be able to watch for changes to topics, but I assume that's possible. That's true basically of any hypercore-based data structure. You can sit and watch any of the hypercore structures for changes and react to them accordingly. Now, I don't know if Hyperdrive has that implemented. I don't know if Hyper-B does. Let's take a look real quick and see if it has a watch command. But yeah, you could certainly do that. And it's an interesting idea. In fact, one of the things that we so there's no watch command written there. I have to look and see what all is inside of the Hyperdrive's watch command to see how easy or difficult it would be to do over here. I mean, it's definitely doable. I just don't know what kind of boilerplate is required to make it happen. But yeah, one of the things that we think is interesting is exactly what you're talking about, having the sort of data sets be treated almost like a messaging bus, where whenever a change occurs, processes can be sitting and watching those changes and then reacting to them. And once we get multi-writer in, that gets really interesting because you could have multiple different devices all watching the same data set and then doing things like pipelines of transformations. So for instance, here's a trivial example, a service that is designed to watch the markdown files for change, and anytime a markdown file gets changed, it automatically writes the HTML conversion as a .html file next to it. And so you can imagine a whole set of services that sit there and watch hypercore structures and then, sort of as like a distributed pipeline. Yeah, I think that would be a fascinating thing to do, and we just need to kind of get our infrastructure to that place. But it's one of those things we've been talking about that forever as like, hey, wouldn't it be cool if? Mario asked, does content deduplication work? So when people ask about content deduplication, they're actually often asking about multiple different things. So there's two different versions of it that I'll answer. The version number one is sort of what you might call a universal deduplication, where it's like if there's a file that's shared across multiple different hyperdrives, for instance, and you have all these hyperdrives on your disk, will they all share the same storage so that, let's say, jQuery.js, it's the exact, let's say you have the exact same jQuery.js in 5 different hyperdrives. Are they going to deduplicate between all of them in the internal storage? So the answer to that is no. That is not currently in there. I think there may be some headway towards that in the near future, or maybe distant future, but not there yet. So that's version one, the kind of universal deduplication. The second one that comes up is deduplication in the history, which is honestly probably not that important of a feature, because what that's sort of getting at is like if you were to write, well, it may not be totally, okay, I'll take that back. Deduplication in the history. So within a single drive, if you write the same file 5 times, does the content of that file get deduplicated? The answer to that is also no. So it's something that's possible, but basically both of those require the system to be sort of producing content hashes of all the files so that it can do the deduplication. There's a little bit of added overhead that comes along with that, but it is a thing that could be doable at some point. Yeah. So yeah, if you save the same file twice, yeah, it'll currently cause it to grow. Now there's a kind of a third related topic, which is just history cache management in general, which is, all hypercore data structures are versioned, and they retain the history of all the versions in the cache so that you can summon previous versions. It's a nice feature to have the versioning, but it means that the stupid data set is growing on your disk and not clearing out old versions of data that you no longer need. And this is what I'm kind of have been referencing when I talk about fixing some of the kind of the details that we have not gotten around to. We need to have some tooling for being able to say, okay, hold on to that thing in history, but the rest of them, go ahead and clear those out of the cache because you're just accumulating cruft by holding on to those. The good news is that we actually took a step forward on that approach. I do agree, versioning is great. So it's, I'm not, oh gosh, what were we thinking? But it's just a downside that we have to get around to fixing. Now we do actually have some headway on that because the first thing that you really need to have the version management is, to have the history management is to have a good way for sort of identifying versions in the history so that you can then say, hold on to version 1.0, but not anything before that and whatever. And we now have those version tags. So you can actually now mark a specific point in a Hyperdrive or Hyperbee. No, actually just Hyperdrive supports this right now. You can mark a specific point in the history with a tag, sort of like get tags, and then have a nice sort of, rather than a random looking number, it can be something like V1.0.0. Once with the tags, we can now do the next step, which is to have some sort of management where we say, keep the data for the following tags, but go ahead and clear out the history for the other tags or untagged files. So small files with small changes win over big files with small changes. 100% correct. Yes, at this stage in the stack, you are much better off breaking up data into small files if possible. So if you're thinking about, for instance, storing a bunch of data in like JSON, don't do one big JSON blob. Break them up into individual JSONs if you can. Okay. So now for the last big step of our app, the data structure detection. I showed this in another stream. I'll show it again. This part is a little bit of an undeveloped part of the stack, considering how common it's going to be needed, and we just haven't quite landed on how we want to address it in a sort of convenient fashion. So I've got some code that I wrote to handle this that I'm going to be more or less copying and pasting in my own projects until we figure out exactly how to handle this in the long run. And those blings are a little annoying, so why don't I'll just mute my computer. What we need to do is we're going to be handed a key, and we need to figure out whether or not it's a Hyperdrive or a Hyperbee. And once we figure that out, we can then load in create the object for the Hyperdrive or the Hyperbee accordingly, and load it all up. So I'm going to open up the code from the Hype CLI. And I hope that I don't have anything embarrassing in my work folder. All right. So there's the Hyper CLI, and I'm going to just go right over to the code that we're going to be grabbing. Okay. Well, my computer's chugging a little bit from the streaming. So let me move this over and expand it a little bit. So this is the code from here to here that we are going to be copying out. And I'm going to step through this piece by piece. So the thing we need to do is all hypercore structures are self-identifying. In the first block that you write to a hypercore, you put at least in Hyperdrive and Hyperbee, they put a header message, which includes in it the first piece of it is it's a proto-buff encoding, and then the first thing is a string in both of them, and that string identifies what the data structure is. And so that's what we need to do. We need to get that first block out of the hypercore, parse the protocol buffer, and then read that string that's in the first thing. And there's a cleaner way in theory to do this, according to Matthias tells me, and I just haven't gotten around to it. And before we continue, I have to let the cat out. So let the cat out, and then we can do this. Yeah, you want out, don't you? Okay, so go with the kitty. Okay, so to do this, I need to grab the protobuf data structure code out of two different places here, Hypertry and Hyperbee. So we're getting into some internal details again, and like I said, we really need to kind of clean this up so it's more approachable to people, because this is a pretty common need. Maybe I'll write a module at some point that wraps this. Hypertry is actually a data structure that hyperdrives are built on top of. This is a detail that most people don't need to know. And in fact, we're talking about moving Hyperdrive over to be built on top of Hyperbees, so Hypertry may end up falling out of the entire lexicon. But Hypertry is where the meat of the Hyperdrive implementation is, and so it's actually a Hypertry message that we need to grab. Go figure. And so the messages, we call them messages, that's just the reference to what the sort of pieces of information being put into the hypercore. Each of those entries, we call them messages, those data structures. So we're going to grab the two message encodings. And I'm going to change this over to old school imports. I didn't even realize I was using CommonJS instead of ES modules, because I usually use ES modules. But anyway, so then what we're going to do is for the key, I'm going to copy this code out real fast, move it over to our thing. So the first thing we're going to do is get a hypercore for the key that we're given. And so we're getting this out of a hypercore, just like we did with the Hyperbee. This will give us the hypercore API, and then we're going to wait till it's ready. Do we need to wait till it's ready? We probably actually don't. We could skip that because we're going to be just doing this right here. We're going to just grab the header block. So block 0 in the hypercore. And then we're going to first assume, this probably could be a hyperdrive, so we'll try decoding it with the hypertry header encoding, right? So we're just calling decode using the hypertry header. And this will throw an error if it's not the correct encoding. So we want to wrap this in a try catch. And if it parses correctly, we're off to a good start. And the type string will actually be hypertry. And so we do if header.type is hypertry. We are looking to find out if it is a hyperdrive. And so if it is a hyperdrive, actually, well, let's do this even more generically. We'll do type. If it's hypertry, then we'll do, yes, we're looking at a hyperdrive. If not, we're going to throw to take us to our next block. And then we're going to parse it again, but this time we'll use the Hyperbee header. So Hyperbee messages, header, decode the header block. And in this one, it calls, instead of calling a type, it says protocol. So if the header.protocol is equal to Hyperbee, then we know the type is a Hyperbee. This could throw as well, so we need to wrap this in a try catch. And if all has failed, then we need to say console.log. I don't know what this hyper is. And then we need to exit the process. Now, we should not hit that because we're controlling what we're passing in, so unlikely. But in your own code, this very well could happen. Now, if it does, you need to handle the error appropriately. Just say something like, I don't support this, and what have you. But okay. So then once that's done, we then just do the appropriate loading code for the structure. So if the type is a hyperdrive, we'll load the drive, and if the type is hypercore, or excuse me, Hyperbee, oh brother, we'll load the Hyperbee. And a nice thing is we can actually just pass the core that we loaded earlier. Now I've got some kind of error here. I missed that parenthesis. And then we're just going to start the server depending on which one we got. And there you have it. So that all makes sense. We're creating a hypercore for the given key, pulling out the header block, trying to decode it for each of the different data structures that we're interested in, and checking that the information checks out. And if it does, then we move forward, and if not, we give up. And then we are handling them according to, which data structure it is. So we have the B key getting passed in, so when I start this thing up, we should get the, all right, we got an error already, get client, right, bad copy pasta. So when we run this, we should see the Hyperbee. We do. And so now if I change it to pass in the drive key, it should appropriately detect that and give us the drive interface. And there it goes. There you have it. So if y'all have any questions about anything I just showed, let me know. Like I said, this code is not great. And is not super clear for anybody, again, given how common needing to detect what data structure you're looking at, because it's the same URL scheme for all of them. This is something that we need to clean up. So if you are hitting on this need and you're like, okay, I don't know how to do this, I would recommend you check out what the Hype client is doing. So it's, I'll show you exactly how to find this code. Hopefully I won't be moving it anytime soon. Hey, kitty cat. So you go to Hypercore Protocol CLI, and it is in lib hyper struct. And this is a kind of wrapper class that I use to sort of encapsulate the many different kinds of data structures and load the correct one, and so on and so forth. So this is, if you are running into this code and need a reference, I would look inside the Hype CLI code base. I will have the most up-to-date solution for this in here. And as soon as we get something that's a little cleaner for people to use, I'll replace this code with that, and hopefully it will be nicely documented in the website, and you won't have to worry about this cruft. Mario asked, how many different types are there? Well, in theory, anybody can build their own type. Right, so I can't actually say, but there are two that we focus on from the course team's perspective, and that is the Hyperbee and Hyperdrive. So two. You could argue that Hypercore itself is its own type. You certainly can use the Hypercore just as a log structure, which is not without value. Two or three, depending on how you look at it. Okay, well, that's, I think, a pretty good stream here. I hope this was informative and useful, and helped get your feet under you about all the stuff that's going on here. Pretty excited about the kind of structure that we're getting set out here. I feel like the Hypercore protocol itself is getting much more clarity and solid footing than it's had previously, and that's really good. Yeah, excited to see what comes next for all of this. We're still deciding about what to tackle next, but we have some ideas that we're cooking around, so I'm pretty excited for 2021. Okay, but yeah, have a great 2021. Happy New Year, everybody, and we'll see you on the next streams.